Okay, class. Today we will discuss about handling. Yes. Okay, class.
Good afternoon, sir.
Good afternoon. Good afternoon.
Yes.
Good afternoon,
I
sir.
want to make one more learner as a co-host, so that sometimes if you are presenting slide, the person can help in joining the others learner. So is there
Okay,
anyone, any learner who want to volunteer for this work?
Yeah, you can add me, sir.
Okay, Mr. Ahmed Tayyab.
Yes, yes, sir.
Okay, I am adding you as a co-host. So please allow others to join while our counselor is teaching. So the class may not be
Yes, sir.
disturbed.
Yes, sir. Yes, sir. I will add waiver requests.
Okay, thank you very much. Thank you.
Okay, thank you,
Sir,
sir.
meeting is over to you, sir. Thank you very much.
Okay, thank you, sir. Okay, class. Today we will discuss about dynamic programming and polynomial and non-polynomial time problems, which are very important for you. At first, we will discuss about dynamic problems and dynamic algorithms. Okay. Actually, in the previous class, we have discussed about some different approaches that consists of your divide and conquer approach, your greedy techniques. We have also covered some algorithms in all these techniques, with all these techniques, and some graph coloring techniques, some graph traversal algorithm. Today we will discuss about dynamic programming. So dynamic programming approach, it is very similar to your divide and conquer approach. As you are in divide and conquer approach, you break down the problem into smaller until you get the complete solution by combining the solution of all the subproblems. So it is similar to divide and conquer approach, the dynamic programming, in breaking down the problem into smaller and yet smaller possible subproblems. Okay, but there is one difference. In divide and conquer approach, these subproblems are not solved independently. Okay, unlike divide and conquer, these subproblems are not solved independently. In it, results of these smaller subproblems are remembered and that are used for similar or overlapping subproblems. This is the difference for your divide and conquer approach and dynamic programming approach. So dynamic programming algorithms are used for solving your optimization problems. We will also explain it with the help of some examples, as we discussed also Huffman coding, knapsack problems. So in in dynamic programming approach, we will also consider an example. With the help of example, we will also explain the dynamic approach. So dynamic programming algorithms are used for solving your optimization problems. We have already used greedy techniques for optimization problems also. So before solving the enhanced subproblem, dynamic programming will try to examine the result of your previously solved subproblems. Actually, it will remember the result of previously solved subproblems. The solution of subproblems are combined in order to achieve the best optimal final solution. We have to find out the best optimal final solution. I have yet not shared the PPT. Okay, I will share PPT. So dynamic algorithm will try to examine the result of the previously solved subproblems. So the solution of subproblems are combined in order to achieve the best optimal solution. Actually, the main goal is to find out the best optimal solution. So we have to find out the best optimal solution. with the help of your dynamic programming approach. So this is your bottom-up approach in which you find out the solution to achieve the best optimal value solutions. So the problem should be able to divide into smaller overlapping subproblems in the dynamic programming approach. And the final optimum solution that will be achieved by using your optimum solution of smaller subproblems, because we have already divided a complete problem into smaller optimum subproblems. So the final optimum solution that will be achieved by using your optimum solution of smaller subproblems. By remembering the solution of these subproblems. So dynamic algorithms use memorizations because the results of these smaller subproblems are remembered and used for similar subproblems. That is used for similar subproblems. So in a problem, there are two properties. According to these properties, we can decide that we can solve the problem with the help of dynamic programming. First comes is your overlapping subproblems. That is your overlapping subproblem. First, that will be your overlapping subproblems. It is similar to your divide and conquer approach. So dynamic programming, it also combines the solution of subproblems. So it is mainly used where the solution of one subproblem is needed repeatedly because the previous result is memorized. So the computed solution that is stored on the table, that is stored in a table, so that these don't have to be recomputed, because once we have computed one solution, we don't want to recompute that solution again and again. So we maintain a table to store the solutions. So this technique is needed where overlapping subproblems exist. For example, your matrix multiplication form. In the matrix multiplication, we will solve with the help of this dynamic programming, matrix chain multiplication, which is also in your syllabus. Then you will find out it. And next characteristic, your optimal subproblems. So a given problem that has optimal substructure property. If the optimal solution of a subproblem of a given problem that is obtained using all solution of your obtained subproblems. Here is also this concept of your memorization. For example, your shortest path algorithm. Every time we have saved the result of previous one. So in the dynamic approach, in the dynamic programming algorithm, we characterize the structure of an optimal solution. And then we recursively define the value of an optimal solution. Here recursive word is very important. And after that, we compute an optimal solution of a subproblem in a bottom-up approach. After that, we construct an optimal solution from the computer information of a whole problem. In case of grid algorithm, the local optimization is addressed. But in dynamic algorithm, we have an overall optimization of the problem. In divide and conquer approach, the solutions are combined to achieve an overall solutions. In dynamic algorithm, we use the output of a smaller subproblem. We use the output of one smaller subproblem to find out the output of another subproblem. Then, in the end, we have find out the optimized result of a subproblem, of a complete problem. So dynamic algorithm use your memorizations to remember the output of your already solved subproblems. We use memorization in dynamic algorithm. So for this, we maintain a table in dynamic approach to find out this result. So it can be used in both approaches, either it is top down or bottom up. So this is your dynamic programming basics. Then we will discuss it with the help of an example. For example, your matrix is chain multiplication. It is the example of your dynamic programming approach in which we multiply 2 or 3 matrices or 4 matrices with the help of dynamic programming. Suppose there are 4 matrices. These matrices are your A1, A2, A3, and A4. These are your 4 matrices. And A1 matrix is your 5:4, in which number of rows are 5 and columns are 4. And in A2 matrix, that is your 4 to 6. A3 is 6 by 2, 6, and A4 is 2 into 7. For example, at first we will understand simple matrix multiplication. Suppose there are 2 matrices. This is one matrix A, and this is one matrix B. This matrix is your 5 by 4, in which 5 are your number of rows and number of columns. And B matrix is 4 raised by 3. Number of rows and its column. Then what will be the resultant matrix? How many number of elements will be present in the C matrix, that is the resultant matrix, and how many number of multiplications are in this resultant matrix? How many multiplications are required to generate the final resultant matrix? And one most important condition for matrix multiplication is there should be the number of column matrix that should be equal to the number of rows in the second matrix. In this example, you can see that in the first matrix, the number of columns are equal to the number of rows in the second matrix. So the multiplication is possible. So A cross B is possible if the number of columns in the A matrix are equal to the number of columns, the number of rows in the B columns are equal. Then the resultant, then the multiplication is possible. But vice versa is not possible. B cross A is not possible. Why? Because here the number of rows and the number of columns both are different. So B cross A is not possible in this example. So in the resultant matrix, for a single element, how will we calculate the value of this single element? By calculating the row and the column. By calculating the row and the column of this, we will find out a single element of this resultant matrix. So, in the resultant matrix, there will be 5 into 3 elements. Total, there should be 15 elements. There will be 15 elements in the resultant matrix C. Result, the first matrix A, in which there are 5 rows and 4 columns. In second matrix B, we have 4 rows and 3 columns. So in the resultant matrix, there will be 5 into 3 elements, and the total number of multiplications total multiplication number will be 5 into 4 into 3. That will be 5 into 4 into 3. That is 60. So, in this matrix multiplication, total 60 multiplications are required. For generating a resultant matrix C, I have to do 60 multiplications in this question, in this numerical. Okay. Now, I have 4 matrices, A1, A2, A3 and A4. So how many number of multiplications are required? If I use a normal multiplication method, so I required a lot of multiplication for above 4 matrix multiplication. So what should I do? So what should I do for matrix multiplication? So the objective of this is to find out the best way in a manner. So what should be the best approach to find out to multiply this matrix? In which approach the minimum number of multiplications are required? I have to use that matrix. So which pair should select that the cost should be minimum? So let's check that. For multiplication of above 4 matrix, in this example, there will be different. Wait a minute. So for this matrix, this is matrix A1, matrix A2, matrix A3, and matrix A4. And it is 5:4. Here 4 into 6. It is 4 into 6 matrix, 6 into 2 matrix, and it is 2 into 7 matrix. Okay. Which pair should I select so that the cost would be minimum? One technique may be I can select A1 and A2 in the first time, then the resultant will be multiplied with A3. After that, I can multiply with A4. This may be one technique. Another may be I can multiply A1 and A2 at first, then A3 and A4, and after that the resultant will be like this. There may be any other possible ways, more than 2, more than 3 possible ways to find out the final solution. If I generate a tree for about 2 problems, then at first I have multiplied A1 and A2, then the resultant is multiplied with A3. After that, the resultant is multiplied with A4. At this stage, I have found out the solution. For the second approach, I can also draw a tree. At first, I have multiplied A1 with A2, and then I have multiplied A3 with A4, and the resultant of both I have found out resultant final solution at this stage. So how many trees are possible? So total number of trees that are possible for calculations for finding out an optimal solution, that will be your 2 into NCN divided by n plus 1. That are the total number of ways you can find out the solution. So in the above example, there are required of 3 multiplication, 1, 2, and 3. Total number of 3 multiplications are required. So there are 5 ways to find out the overall solution, the total solution of the above multiplications. So in this example, there are 5 ways to find out the solution. So in these 5 approach, what should be the approach to find out so that the cost should be minimum?
Excuse me, sir.
Yeah, tell me.
So what is this NCN? N is the number of matrix, and what is this C?
It is combination. You have already read about it in your BCA and in your maths class. NCN, permutation and combinations.
Okay. Can
I
you
said,
just
you know this. NCN, that is your combinations in the mathematical. Okay. 2 into
okay?
NCN divided by n plus 1. That is a simple math formula. Okay. So total number of 5, there are total 5 ways in which you can parenthesize these equations, this problem. So what should be the easy approach by applying the dynamic programming? Or what pair should I select so that the cost should be minimum? That is the goal in the matrix chain multiplication. Matrix chain multiplication is one of the important dynamic programming example in which you have to find out which pair should I select so that the cost should be minimum to find out the best solution, to find out the optimal solution. So there are 5 ways. So what pair should I select? That is the objective of this matrix multiplication. That is the objective. Now we will find out the solution. The solution is this is the problem. This is also called your tabulation method because in the dynamic programming we use tables to store the result of your previous solutions so that I can use the previous solution for my further use, for my further calculation, because every time I will not calculate the same result again and again. I will use just that result. So this is the problem. A1, A2, A3 and A4. This the main problem is 5 into 4, that is 4 into 6, 6 into 2, and it is 2 into 7. So I will draw a table for this matrix multiplication. We have 4 matrix, so I have drawn a table for 4 and one more table. So that table is your S. That will tell us which pair should I select. Okay. So this is your bottom-up approach. In the first step, in the matrix multiplication, if I multiply A1 by A1, it means if I calculate M1 by 1, only there is a single matrix, then the cost of this multiplication should be 0 because there is only a single matrix. So I will put this value M1 and 1 because it is not multiplying with any other matrix. Same as A2, M of cost of this, there is a no multiplications, M2 by 2, the value should also be, the value would be 0. Same as A3, the value will also be your 0. I will write down here. And for A4, the value will also be your 0 in the first step. Then now I'm in the first way. Now I'm multiplying these two matrices A1 and A2. Now I'm multiplying A1 and A2. So second matrix A1 and A2, that will be A1 multiplied with A2. So how many multiplications are required? What should be the cost? So A1, in A1 it is 5 by 4 matrix and A2 is your 4 by 6 matrix. So total number of multiplications should be the total number of multiplications should be 5 into 4, 4 is common, into 6. So the value is 120. So we will write down it in the M1 and 2 location here. Here should be your 120. Okay, this is your 120. We have already calculated this calculation in the previous example. How we find out this value 120. Okay, now I am calculating, I am multiplying second matrix with third matrix, M of 2 and 3. I am multiplying second matrix with third matrix. One approach should be like this, A2 and A3. So A3 matrices were 4 by 6 matrix and A3 is your 6 by 2 matrix. So total number of multiplications, so the cost should be, this is similar, so 4 into 6 into 2. That should be 48. So I will write this 48 value in M2 and 3 location. M2 and 3, 48 is here. Now one more way, I will multiply A3 matrix with A4 matrix. That will be M of 3 and 4. After calculating the value, that will be your A3 multiply with A4. So that will be your 622227. So the cost should be 6 multiply with 2 multiply with 7. So the value will be 84. I will write down it, third is 4 location 84. So I have find out the first citation in which I have multiplied only two matrices. At first I have multiplied A1, A2, then I have multiplied A2 with A3. After that I have multiplied A3 with A4 in the first one. Then I will multiply three matrices A1, A2 and A3. So how will I calculate this? Just note down each steps very clearly. Otherwise, you will not able to understand this. In dynamic programming and as well as in your NP problem, it is very important to note down every step and to understand every step. Okay, so now the next is M1 ratio. I'm multiplying these three matrices. That should be M1 to 3. That is A1 multiply with A2 and A3. Now there should be two approach to multiply three matrix. First should be, at first I am multiplying these two, or I am multiplying A1 and A2 first, then I am multiplying this resultant with A3. There should be two approach in multiplying three matrices. In the first case, by multiplying only two matrices, there is only one way. If I am multiplying three matrices, so there are two ways to multiply this. So I will have to calculate both the ways, the cost of both approaches. So in the first approach, A1 matrix, that is your 5:4, A2 is your 4:6, and A3 is your 6:2. If I calculate the cost in the first approach, then by multiplying a single matrix, it is a single matrix, so the cost should be M 1 by 1, because it is not multiplying in the starting, plus I am multiplying A2 with A3, that is A2 of 3. That is A2 of 3. Plus, by multiplying this matrix and this resultant matrix, the cost should be 5 4 into 2. 5 into 4 into 2. That should be the cost. Then the value of M11, that is your 0, and the value of M223, that is your 48. You can see that this value is already stored in the table. We have saved this value in the table. Now we are directly using this value in the dynamic approach. I have told that in the dynamic approach, the solution of previous subproblem, that is stored in the table. And after that, if we have to use it, we will directly use the solution, use that from that table, because dynamic approach use your memorizations. That is your 48, and this value is your, that is your 4. Now it is 40. So overall cost is your 88. In the first approach, the cost is 88. Now in the second approach, I will do the same. I will find out it is A1 is your 5:4 matrix, A2 is your 4:6 matrix, and A3 is your 6/2 matrix. So the overall cost would be M1 and 2, because I am multiplying A1 and A2, so that should be the cost, and A3, the cost would be M3/3, and the cost by multiplying these, that should be your 5 into 6 into 2. Now, the 1, 2, 1 and 2, the value is 120 plus M3 by 3, that value is 0, and 5, 6, that is your 60. So the overall cost in the second approach, that is your 180. Now you can see that in the first approach, if I have applied this one, the cost is 88, and if I applied this way, then the cost is 180. Then I will select the minimum, which have the minimum cost. The minimum cost is here. In the both approach, I will check the minimum cost. The minimum cost is 88. So the overall resultant of these should be 88. Now the cost of multiplying these three matrices will be your 88 because it have minimum. So I will write 1:3, that is 1 into 3, that is your 88. Now I will calculate next. What is next? Next is multiplication of A2, A3 and A4. Now I will multiply this. At first we have multiplied A1, A2 and A3. We have multiplied three matrices. Now we are multiplying next three matrices, that are your A2, A3 and A4. The next matrix are your A2, A3 and A4. So that will be your M of 2 and 4, because we are multiplying A2, A3 and A4. So we can also multiply these three matrices according to two ways. At first, I can multiply A3 and A4 first time, and the resultant is multiplied with A2, or A2 and A3 multiplied at first, then the resultant is multiplied with A4. So in the first way, in the first approach, if we calculate the cost, we can see that A2 is your 4 by 6 matrix, A3 is 6 by 2, and A4 is 2 by 7 matrix. So the cost would be for A2, it is a single matrix, so the cost would be M2 and 2 plus M3, 4, and this cost is already calculated in the previous iteration, and for multiplying all three matrices, the cost would be, the total number of multiplications would be 4:6:7. 4 into 6 into 7. So the value of this is 0 plus this is already calculated, that is your M3 to 4, that is your 84, plus 4 into 6 into 7. If I calculate this, this value will be 764, that is your 168. So the overall cost is your 252 in the first approach. In the first approach, when I have multiplied A3 and A4 first, and the resultant is multiplied with A2, then the cost of this is 252. Then in the second approach, at first I am multiplying A2 and A3. This is 4:6 matrix. This is again 6:2 matrix. And this is your 2 into 7 matrix. If I am multiplying A2 and A3, the cost should be M of 2 and 3 plus A4, that should be M of 4 and 4, and by multiplying these three matrices, the cost would be 4 into 2 into 7. The value of M of 2 of 3, that is your M of 2 of 3, that is your 48, plus 4 by 4, that is your 0, plus that is your 56, 8 7 are 56. So the cost is 104. Okay, so in the first approach, we can see that by multiplying these three matrices A2, A2, A3 and A4, if I use first approach, then the cost is 252. If I use second approach, then the cost is 104. And now I will check the minimum value, which have minimum value. So the minimum value is 104. So I write down this value in M of 2 of 4. In M of 2 of 4, the value will be 104 because it is the minimum cost, 104. Now, we have find out in the first approach, I have calculated the single matrix. Then I have taken two matrix multiplications. Now I have covered three matrix multiplications. Now we will multiply all the matrix, all the four matrices. And the sub-problem solution is already stored in the table. In the table, you can see the solution. In the table, you can see the solution. Okay. So the final one, the last one is, the last approach is your, I am multiplying A1 to A4, all the matrices. So how will I calculate this? How many ways I can calculate? If I am using only two matrices, that there is only a single way. If I am using three matrices, then there are two ways to calculating two multiplications. If I am using four matrices, then there should be three ways for multiplying these matrices, and I will find out the minimum cost in all the three ways. So I will calculate all ways. In the first way, what should be? At first, I'm taking one matrix plus I'm calculating A2 to A4. That is your M2 of 4 first in the first approach, and the cost would be here by multiplying all the matrix, that should be 5 ratio 4 ratio 7, because we have taken first here, then we have multiplied all these three, because I have calculated the result of these three matrices in the first way. Or in the second, I am multiplying at first the first two matrices M of 1 and 2, then I am multiplying these two matrices M of 3 and 4, and the overall cost of calculating all the four, that should be 5 into 6 into 7 in the second approach. In the third one, I am calculating these three together. 1, 2, 3 plus one is individual 4 by 4, and the cost is, now the cost is 5 is your 2 into 7. Into 7. So in the first approach, this is second approach, and this is your third one. So in the first approach, if you calculate the cost, this is your 0, and M224, M224, this the value is 104 plus this value. This is your 5 4 ja 20, 140. This is your 140. In the next, M1 ratio 2, this is your cost 120 plus 3 in 3 4, the value is 84 plus, if I calculate this 5 into 6, that is 30, 30 into 7, 2110. The value is 2110. In the third, F13, the cost is 88, and this cost is your 0 plus, and this value, this is your 10 into 7, 70. Okay. If we check which is minimum, then you can see that 104 plus 140, that is greater than 200. That is your greater than 200. 120 84, that is approximate your 400, and this is your 158. Okay. The first approach, the cost is your cost is greater than 200. In the second, that is also your greater than 400. In the third one, the cost is 158. So I will consider the minimum one, which cost have minimum. So minimum cost is your 158. By multiplying all the four metrics, the value is 158. Now I have find out this value, that this is your 158. So in the matrix multiplication, I have find out all the value by multiplying all the four items, all the four matrix in the matrix chain multiplications with minimum cost. At first, I have calculated a single matrix cost that will be 0. Then I have calculated the cost of multiplication with of two matrix, that is written here. Then I have calculated the cost by multiplying three matrices. At the end, I have calculated the overall cost of multiplying all the matrix, all the four matrix, and that is your 158. So I have calculated all the solution, optimal solution, with the help of this. Okay. Now, what is the role of this table? The role of this table is for parenthesize. When I have calculated the value 120, the 120 value, that was your based on your by selecting the first matrix. So the value was your 1, because it is based on, it is purely depend on the first matrix. So that was 1. As well as here I have calculated 1 3, that is 1 and 3. In 1 3, what's the cost in which it was minimum? That was your A1 and A2 and A3. in which I have first calculated A2 and A3, then I have multiplied with A1. So that is also 1. And in next value is 2, 3. In the 2, 3 part, it is dependent on the second 2 matrix. So this is calculated. A2 and A3 purely depend on A2. So that is the value is 2. And in the 2, 4, it is dependent on your 3 part matrix 3. When I have calculated 2, 3, because the minimum cost was your, by multiplying these two values, that was 3. In the third one, when I have calculated 3, 3, it was also depend on your 3. And here it was also depend on your third one. Okay. Then if I parenthesize these sum, then you can check that the overall tree, binary overall tree of this matrix multiplication is by calculating this in the complete solution, you have checked that, you have calculated that in A1, A2 and A3 and A4A, at first I have multiply at first A2 and A3. In the first, at first I have multiplied A2 and A3 in the first, then I have find out a solution. Then this solution is multiplied with A1 and this solution is further multiplied with A4. Then I have find out the overall minimum solution. So that is your, at first I have multiplied A2 and A3, then multiplied this solution with A1, and then this is multiplied with A4. This is overall parenthesis of this matrix multiplication. If I generalize, I make a formula for this, then the formula should be M of I comma j, that should be minimum of, minimum value of the cost of I to k in the first matrix, and next from k1 k plus 1 to j. So I have covered all the matrix. In the first I have I to k, then k plus 1 to j, and the overall cost. What is the cost? What is the cost? Suppose here the cost is D0, here the cost is D1, the cost is D2, and the cost is D3, then I will D I minus 1, sorry, I minus 1, not, that will be multiplied with D of k, this value, into multiplied with this value, that is D of j. So this will be a generalized formula for this matrix multiplication. So this is the final generalization formula of this matrix chain multiplication problem. So in this method, what should we do? In this method, we have characterized the structure of an optimal solution. we have divided the problem into subproblems. Then we have recursively defined the value of an optimal solution in this method, in this example. And we have computed the optimal solution in a bottom-up method. You can see that in the bottom-up method, it's a bottom approach. From bottom to up direction, we are calculating the overall solution. We have computed the value of an optimal solution in a bottom-up fashion. And every time the result is stored in the table. Every time the result is stored in the table. So that next time we can use the previous result that is already stored in the table. So this is the characteristics of your dynamic programming, because we use memorization. Dynamic algorithms use memorizations, as we discussed first. Then we have construct a optimal solution from the computed information. We have find out the minimum number of calculations required for your matrix multiplication problem. So in this manner, we have find out the minimum solution, the optimal solution. So dynamic programming that is used in both top-down approach and bottom-up approach. And most of the times, the previous solution output is cheaper than the recomputing the new one, so that we save this solution in the table. So this is your dynamic programming approach. And this is one of the best example to check that, to calculate your dynamic programming approach. There are other examples also. You can see knapsack problem. We have already discussed your fractional knapsack. So in dynamic programming, with the help of 0-1 knapsack, you can choose Tower of Hanoi problems. So these are your dynamic programming approaches which we are required. So next important topic, and very tough topic, you can also say very tough topic, that is your polynomial and non-polynomial type algorithms problems or complexity problems. That is one of the important and tough, and you can say complex topic which we will discuss. That is your P, NP, NP hard, and NP complete complexity classes. Now we will discuss this. Now the next topic is that is your PNP, NP hard, and NP complete problem. It is one of the most important problems, and it is not easy to understand also. If someone want to leave, kindly leave. Otherwise, don't leave until it is finished. Otherwise, you will not understand it in a single bit. Okay. At first, we will discuss about what is the algorithms. We have already discussed so many algorithms in this course. So now we are categorizing the algorithms in two ways. These are your polynomial time algorithms and exponential time algorithms. First one is your polynomial time algorithms. These are your polynomial time algorithms. And second one is your exponential time algorithms. For example, your linear search, your binary search, or you can say any type of sorting, your insertion sort, your binary sort, sorry, binary sort, your merge sort, your quick sort. These are different polynomial time algorithms in which we have seen that the complexity of this is your n, binary search, the complexity was your log n. This is insertion sort, the complexity was your n square. Merge sort, the complexity is n log n. And in the quick sort, the complexity is your n square. In the worst case, I'm talking about worst case. Okay. Exponential time algorithms we have already discussed. For example, your knapsack problems, your traveling salesman problems, or your some of subset problems. These are some problems which cannot execute in your linear time, in your polynomial time. Actually, it takes your 2 to the power n time for executions. So there are two types of problems. First one is your polynomial problems, which we have discussed so many times that we have already calculated the complexity of these algorithms. It includes your searching algorithms, sorting algorithms. Normally, your all the algorithms which are Huffman coding algorithms, okay, in which we have find out the solution within a deterministic time in a polynomial time. Those algorithms are called your polynomial time algorithms. So next algorithms are your exponential time algorithms, in which the solution is not find out in a polynomial time. That is find out in the exponential time. So the first objective, the objective of this problem, the objective of this is, the first objective is, at first we want to solve these problems to find out an algorithm so that it will be executed in a polynomial time. And that is the goal. We want these exponential time algorithms, we want to solve these algorithms in a polynomial time. So the first objective is, if we are not able to find out the solution, what should we do? The first objective is just try to relate all the problems. Of this side and to find out the relationship between these problems. Actually, these problems are open problems. These are very famous in the researchers. Anyone can do research on these problems. Anyone can solve. These problems are still not solvable problems. So our goal is to find out a solution. If we are not able to find out the solution, what should be the first objective? First objective should be to try to relate all the problems, to find out a relationship between all the problems. Because if there is a relationship, if we find out the solution of any problem, then we are able to find out the solution of our problem. So there is a need of relationship among all the problems. So first objective is we try to find out a relation among all the problems, a relationship between the problems, so that if we find out the solution of a particular problem, then we will find out the solution of all the problem. That should be the first. Then the second, what should be the second approach? Sorry, second objective. Second objective should be, when you are not able to write any algorithms for this side of algorithm, where you are not able to write any algorithm in a polynomial time, then why you not write a algorithm in polynomial time that is non-deterministic? We are not able to find out, we are not able to write an algorithm in a polynomial deterministic time. So we will try to write a polynomial time non-deterministic algorithm for this, so that if we find the solution of polynomial time, then that will be saved for the researcher. For example, I am talking about a simple searching. In the linear search, it takes order of untime to execute to find out a particular element. Suppose I'm implementing a new search, any search. Suppose I'm writing an algorithm that is named as K search. Suppose K search. This is a new algorithm to find out any element of a size array A, and the element is n. Array A, the size of the array is n, and the element is key. Okay, I have to find out the element in this array. In the linear search, the complexity is n. I'm trying to write down a non-deterministic algorithm. So I'm writing J. Suppose I have used one choice. This is a function. If I'm comparing, if the key equal to A of I array element, then write that element position, and now you can say that success. This successfully found. Okay, otherwise it is failed. The non-deterministic algorithm will be the algorithm in which all the elements should not be non-deterministic. There will be some code, some area which is non-deterministic. Remaining codes will be your deterministic. So this is a searching algorithm in the non-deterministic manner, in which I have to find out a key. This takes one time. This takes also one time. This takes one. These three steps, these are your non-deterministic, because we don't know the code of this. We don't know what should this do. Actually, we are checking that if the key value is equivalent to the array position, just write that. How this key value is calculated, how this value is now find out. This is non-deterministic. We don't know this. So this is non-deterministic. Suppose this is done in constant time, this is done on constant time, this is also done in constant time. So overall time should be constant time. So we have calculated this linear time solvable problem in the constant time. So this can be your non-deterministic algorithm. Any algorithm, when we don't know how things are working, we generally call it a magic. If we know the solution, then this is a technique. For example, merge sort. Merge sort is implemented in 1945. Before 1945, this problem is NP problem. You cannot solve in the polynomial time. Merge sort. After finding the solution, this is polynomial time. So in the non-polynomial algorithms, suppose this is a graph, this is an area of non-polynomial time algorithms which are not executing. Under this, there is a set of polynomial problems. Before 1945, merge sort also exists in this area, in NP problem. After finding the solution, this is here. Now this is here, merge sort. So I have told that when we don't know the things are working, we call it magic. At that time, people think that this is a magic. How will we do then? Once we have find out the solution, once we know how it works, just it is a technique. Now it is a merge sort technique, the divide and conquer technique. If you don't know this, then that is when you standing thing. So all the NP problems can be solved in polynomial time in future. So you cannot say that this cannot be solvable. For example, your merge sort, that is unsolvable at that time. Okay. So we will discuss some basic terminology in this. There are some problems which are your decision problems and deterministic problems. I will discuss at first, then I will discuss NP problems. I am sharing a screen. After that, I will also share this. Is it visible?
Yes, sir.
Okay. There are some basic terminology which we use in this topic. The first is your tractable problem. Okay. Tractable problem, a problem that is solvable in a polynomial time algorithm. That is called your tractable problem. We can solve this problem in a polynomial time. It means the maximum time complexity, the upper bound of these problems, these algorithms that will be in polynomial time. These are your pure tractable problems. Next is your intractable problems. Intractable problems are problems that cannot be solved by polynomial time algorithms. A polynomial time algorithms, which we have already discussed, with the help of these polynomial time algorithms, we can now solve these problems. So these problems are called your intractable problems. It means the lower bound is exponential. And from the computational complexity stance, these problems for which there exists a efficient algorithm to solve. It means we can verify these algorithms in a polynomial time, such that brute force approaches are used, in which hit and trial methods are used to find out the solutions. Every time we hit and trial method will use to find out the solutions, because this in a proper way we cannot find out the method. We have checked all the permutation and combinations of the solutions. However, these problems does not provide an efficient solutions. So, therefore, these are not feasible for computations with anything more than the smallest input, because these are open problems. You can also solve these problems. Everyone can solve these problems. You can write some deterministic code and save that code for future use, and just write down the functions, non-deterministic functions between that code. If some other person find out the code, the deterministic code to solve that problem, he will write the functions of that deterministic code. You have already saved the deterministic part. You can do that. Next comes in your decision problem and optimization problem. So decision problem is a problem that can be posed as question. It means it has a question and yes and no answer. For example, in a 0-1 knapsack, if there is a capacity, you can put in either yes or no. If you have no capacity, just leave it, just discard it. So this is a decision problem. And optimization problem, this problem is in which the goal is to find the best solution among a set of possible solutions. If, for example, suppose to determine whether a in a given graph there is a cycle or not. In the decision problem, you can just answer. You can phrase your answer either yes or no. Does the given graph have an odd cycle, or you can say yes or no. Or to find out the shortest path between 2 points, you can check that. Is there any path between 2 points? You can say yes or no. This is your decision problem. So in general, optimization problem involves your finding the maximum or minimum value of some objective functions. It cannot be phrased as yes or no questions. It involves the finding the maximum or minimum value of some objective functions. And in decision that do not have any objective functions to optimize, they simply involve determining whether the given statement is either true or false. In the 0-1 knapsack problem, in the optimization problem, we have given number of items, profits and weights with each item. And we have also the capacity of knapsack, also maximum weight of the knapsack. So in 0-1 knapsack problem, you will always determine the maximal total profit of items that can be placed in the knapsack. While in decision making, if you are talking about the knapsack decision problem, if I'm talking about the decision problem in the knapsack, the objective of the decision problem is to determine whether it is possible to earn a profit not less or equal to some amount. You are given some amount. Now comparing with this amount, is the profit is compared with this amount or not? You can say that either it is not exceeding the maximum knapsack capacity or not. You can say yes or no. This is the decision problem. This is your decision and optimization problem. Next is your deterministic and non-deterministic problem. So deterministic algorithm is a type of algorithm in which the result of every algorithm that is uniquely defined. For example, we have discussed so many algorithms: linear search, binary search, quick sort, merge sort, any algorithms. The result of these algorithms is uniquely defined. So the deterministic algorithm performs a fixed number of steps and always get finished with accept or reject the state with the same result. In the deterministic algorithm problems. So deterministic algorithms, they can solve the problem in a polynomial time. In the polynomial time, they can solve the problem. And all the deterministic algorithms always have a single outcome. That is a single outcome, single output. That is, the input is given to it that always results some output in the deterministic algorithm. While in case of your non-deterministic algorithm, in the non-deterministic algorithm is one in which the output of every algorithm is not uniquely identified, and not uniquely defined. If you have executed the algorithm first time, you will find different result. If you have executed the algorithm another time, you will find the result different, because that is not uniquely defined. Thus, the result could be random in the non-deterministic algorithm. So the non-deterministic algorithm have many outcomes, multiple outcomes, because the outcome is not defined. that is not uniquely defined. The outcome should be your random. So it takes your maximum multiple execution power. So it is very difficult to determine the next state of the machine in the non-deterministic algorithms. And it cannot solve the problem in polynomial time, non-deterministic algorithm. Because the output is random. You cannot solve in a polynomial time. That is not possible to solve the non-polynomial, non-deterministic algorithm in a polynomial time. But you can generate, you can implement an algorithm for that, because all the polynomial problems that are the part of your NP problems, non-polynomial time of problems. So in computer science, there exist some problems whose solutions are not yet found. These problems are divided into the class that is called your complexity class. Because we have yet not find the solutions of these class problems. On these classes help scientists to group problems based on how much time and space they are required to solve the problems and to verify the solutions. You can also read it in theory of computation subject also, where you can also see the CNF Chomsky normal form complexity classes in the theory of computation subject. So the common resources are your time and space. We will always talk about your time and space. It means how much time the algorithm takes to solve the problem, as well as the memory uses. So the time complexity of algorithm that used to describe the number of steps required to solve the problem. And it can also be used to describe how long it takes to verify that answer. And the space complexity that describes how much memory is required for the algorithm to operate. How much memory is required to execute that problem. So these type of algorithms, these type of complexity classes that are classified into different classes problems. The first class is called your P-class problems. P-class problem, this stands for your polynomial time problems. The first one is polynomial time problems. The first P-class problem, that is your polynomial time problems. It is a collection of those decision problems. It is the collection of decision problems that can be solved in a linear time, in a polynomial time. That can be solved in the polynomial time. That are efficiently solvable problems. We can solve it in a polynomial time. And the solution is easy to find. We can find the solution of these type of problems. Then these problems are called your polynomial time problems. What are these decision problems? Decision problems are those problems in which you can verify either it is yes or no. So P is a class of computation problems that are solvable and tractable. Tractable problems. Tractable means, as we discussed earlier, tractable means the problems can be solved in theory as well as in practice in a linear time, in a deterministic time. If that is not solved in the theory, okay, that are the problems that can be solved in the theory as well as your practice, in your practical. That are your tractable. Otherwise, they are irretractable. So all the design problems, a problem that is said to be polynomial if it can be solved in a polynomial time using a deterministic algorithm. Then it is called your polynomial P algorithm. For example, your linear search, your binary search. So polynomial algorithms that will be solved or verified, that can be solved and verified in polynomial time, our P time, our polynomial problems. Next is your NP problem, non-deterministic polynomial problem. A problem that cannot be solved in polynomial time, but there is one constraint, but that can be verified in polynomial time using some non-deterministic algorithm. Then it is known as NP problem. It is very clear. A problem that cannot be solved in polynomial time. We cannot solve in polynomial time, but they can be verified in polynomial time by using non-deterministic, I'm told non-deterministic algorithm. Then that is called your non-polynomial time algorithms. This is non-polynomial in nature. It is the collection of your different problems that can be solved by a non-deterministic machine, but in polynomial time. And the solution of these NP class problem, it is very hard to find, since they are being solved by your non-deterministic machine. But you can easily verify that with the help of Turing machine. You will learn in the theory of computers and Turing machine. So NP problem can be verified by the Turing machine in the polynomial time. For example, your Sudoku problem. In the Sudoku problem, in which you put 0 to 9 number in a box. For filling that box, you check all the solutions. You find out all the possibilities. You use all the methods so that no element can be repeated in the same row or same column. So it takes a lot of time to complete a Sudoku. But if you verify that, if you check that within a limited time, you verify the final solution, you verify that problem, your Sudoku problem, verify that within 2 to 3 minutes, it is correct or not. So those type of problems are called your non-polynomial time problems, NP problems. These problems are called your NP problems. Next is your NP hard problems. NP hard problems are those problems, the problems that cannot be solved in polynomial time. That cannot be solved in polynomial time. That are called your NP hard problem. NP problem is hardest problem in NP, and it is a class of problem such that every problem is NP reduces to NP hard. Okay, a problem, for example, a problem X is NP hard if there is an NP complete problem Y such that y can be reduced to x in n. It means in the graph, if this is a graph, if this NP problem, this is reduced to your NP hard in polynomial time. Thus, then these type of problem, they are hardest problem in long time. Takes a long time to check whether it is right or not. It is right or wrong, but it means it is verified within a time. But in NP hard, it takes a long time to check whether it is right or not. So a problem A, NP hard, if for every problem type of problems are called your NP hard problem, NP problem, NP complete problem. So if a problem A that can be reduced into n problem, that is reduced into, if a problem that is reduced into NP problem, B is polynomial time, problem A will be NP complete problem. Okay, a problem if it is both in NP hard and NP. If a problem is in both in NP hard and it is a intersection, if a problem is in both NP hard and NP, then it is called your NP complete problem. NP problem, because NP problems are the problems which we can find out the solution in future for these type of problems. These are your NP hard problems, so that P is a part of your NP. Okay, so if one could save the NP complete problem in polynomial time, then we can solve the NP problem in polynomial time. For example, Hamiltonian cycle, 0-1 knapsack, satisfiability, these are your NP complete problems. These are your NP complete problems. So polynomial problem, the polynomial problem that is easily solvable in your polynomial time. Okay, and NP problem, the NP problem cannot be solved in polynomial time, but the answer can be checked in your polynomial time. For example, in a Sudoku example, this is your NP problem. NP hard, all NP hard problem, hardest in the NP are not NP, because it takes a lot of time to check it is true or not, to verify that. That is one. And a problem that is both in NP hard and NP, that problem is called your NP problem. That is called your NP complete NPC problem. For example, we have already write down here. NP hard is your quantified Boolean, Hamiltonian cycle, knapsack problem, Hamiltonian. These are NP complete, graph isomorphism is your NP problem, and these are P problems are your all algorithms which we have discussed earlier. All are your P problems. Okay, this is your P and P complete and P hard problems complexities. Okay, I think this is enough for today. Okay, class. So in this class, we have discussed about your dynamic approach, dynamic programming, in which we have discussed it with an example. The example was your matrix multiplication, minimum matrix multiplication method. Then we have discussed about the complexity classes in which discuss about the PNP, NP hard, and NP complete problem. Okay. Actually, this topic is very hard and very boring, you can say. It is not easy to understand in a single time. You can ask me this topic personally
So
also.
do we have another class next time?
Next, I will check. Okay.
Sir,
So I think
can you
the
hear?
session, sixth session already done.
What?
The
Classes
sixth
is
session,
already
sixth
done.
class is already done.
Okay. Okay. We have.
Yes, sir, six. So do you have another class or not?
In my, I will check in my. Okay. I will
Sir,
check that I have class or not. Otherwise, we will discuss. Okay, we will discuss. After the class, we will also discuss. Okay. Just send me the message that you want to discuss in this topic. We can discuss it. Okay.
sir, would you please highlight the important topics in whole subject? Which
Okay,
are
okay.
the important
Okay.
topics which are mostly coming in the exam? It is really important to us.
Okay. Actually, I have already covered the most of the important topics in according to your syllabus. Okay. I will note down all the topics in a paper. Then I will send it in the group.
And also,
Okay.
if it is possible to share us some previous question papers in the group or in WhatsApp group, it's really appreciated.
Okay. Okay. I will try for that.
Thank you.
Okay. Okay, class. Okay. Thank you, class.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, class. Thank you. You may leave now. Okay. Thank you.